Hello, hi, and welcome to today's tutorial. Um, I'm Hamza Afridi, and today we're going to be looking at one of the new features on Kaggle, where we can train our reinforcement learning models, play around. There's an interesting competition that is happening in at Kaggle as well. So we're going to explore that. It's called Connect Us, and I'm going to show you how to get started. For this, you might need to have certain understanding of reinforcement learning to follow through. But just to give you a rough idea, and maybe it's a good point for you to start, it's the basic concept of reinforcement learning is that you need to have, you have two things. You have an environment and an agent. What happens is the agent plays or does something in the environment, and environment gives the feedback whether the action that the agent performed was a positive or a negative one. So for example, if you're playing a game, you as a player is an agent and the game is the environment. So environment is going to tell you what you can do, what you cannot do, and then give you feedback. As an agent, you'll make a move, and the environment will tell you whether the move was a good move or not, or a neutral one. So this is basically the entire reinforcement learning model is essentially. So let's get to it. We have Kaggle here, and there's an interesting competition happening called Connect X, and all you have to do is sign up. I have already done that. Once you do, you can then submit an agent. Currently, I was working on one of my notebooks. So let's do that. So it's a private one currently, but it's very interesting. It's something that the Kaggle guys already have compiled. So first thing that you need to do is basically you need to have from Kaggle environments, you need to get make and evaluate. So what does make do? So it basically gets you the information, right? Gets you the environment that you need to work on. So first thing first, you need to import the particular library and then start the Kaggle environment, and we are going to be using it in a debugging mode, so which means that we will have all the feedbacks that we require. For example, if we were running a script and we were running it in background, training it, it would be very different. So with this example, we'll certainly have a very in-depth analysis of step-by-step analysis of what is possible with reinforcement learning and what are the bases of reinforcement learning, especially on the agent side where the decision is being made. I'll show you how to make that happen basically. So as it loads, we are going to first try out a few of the agents that Kaggle already has implemented. It's very basic. One is random. What it does is so you have this game, and it does you have certain number of actions. You perform any of the action randomly, and we'll see how that works out. And then there's another one, we'll explore that as well. Later on in this notebook, what we are going to do is we are going to implement 3 other models. First, we are going to remodel the random one, and then we're going to design and implement basically agents. So the first one is going to be the same one that Kaggle has already implemented, the random one, and then the second one will be where we will perform different types of actions. So as this is the session has started, first thing first, what we do is we get this environment. We import, make, and evaluate from Kaggle environments. We set up the environments, and we want to see which agents do we have. So currently, these are the built-in ones that I was talking about. If I run this, I see we have 2, random and a nega mix. So now this is very interesting. Now we are running the simulation. We are running the model. So there is within the environment object, env object, it has a run function. What it does is you can have two different agents playing with each other, right? So this is a two-player game. I'm sorry, I didn't mention which game this was. This is basically a game where you have to throw in the coins. So this is a two-player game. You throw in the coins, and the idea is to have 4 coins in a line, right? As this renders, you will be able to see it. So let me run the cell. What it does is it has a random, it runs the random internal and then a nega mix internal models, agents, and it plays with each other. So the environment render, what it does is it gives us this beautiful simulation. So it shows that the game completed in 25 steps. So what was the first step? Nothing happened. The first move was by random, placed it somewhere. And then the second move was by Negamax. Again, pretty random, nothing serious. Again, random. And as you can see, it plays on until you get a line. So that's where you win, that's where the game ends, that's where the environment says, okay, that's it, no more. The next step, as I discussed, would be to actually implement our own agents. So let's first implement a random agent that's already been implemented before and see how that will look like. So first thing first, there are 2 things here. We have for this competition to work, if you're implemented an agent and you are giving it to as a submission to this this competition, first thing the structure that they've provided, you have to follow that. So it's going to be a Python function, and it will have two arguments. One is going to be OBS, the observation, and one is configuration. So it could play for different configuration. In configuration, we have the size of the game. So for example, this one that we were playing, it's 1 2 3 4 5 6 1 2 3 4 5 6 7 6 by 7 a table, and the rule of the game is that you need to have 4 in a row. So maybe you want to have 2 in a row, 3 in a row. 2 won't make sense, but 3 in a row, 4 in a row, 5 in a row. So whatever makes sense, right? So the competition is going to be making different kind of approaches to evaluating your agent. So that's there. So what we would first do is we would extract the number of valid moves that we have available, right? So this script is basically what it's doing is we have a number of columns, right? And then a number of boards. So wherever the board is empty, we could place our move. And once we have a list of valid moves, what we'll do is we'll use a function within random library called random.choice, which will help us randomly choose among the choices that we have. The function expects that we return an integer value, which is going to be the column value where this where we need to place our move, right? So then there is another agent that we have implemented, that is agent middle. What it does is always returns or places a move in the middle. Then the other one is the leftmost. What it does this time is basically it takes all the valid positions, as we did in the random one as well. It takes all the valid columns, that is, the column isn't filled, and it will make a move on the leftmost one, right? So it's another agent, very simple one. This is something that has already been provided by the Getting Started notebook already, but the reason that I'm doing this is basically to make you understand, and probably there are people who would understand more by listening. So now what we do is we put this to test, and similarly, as we did previously, we have a function with an environment, that is environment.run. And once we do that, we can make our agent talk to play with each other, right? We can play with the agent that has already been implemented. Now, one thing that you might have sort of noticed is that this particular whenever I run this agent, whenever I run this environment, every time the number of moves it takes to win the game changes. Like, for example, this time we had 16. Now let's run this again. 9. Well, so it's completely random, and you can expect more steps to complete or win, and maybe sometimes less steps as well. So usually what you do is you run a long simulation. That you don't play just one game, you play multiple games, and then you get the win percentage. So for example, we might want to play this game 100 times and see what the results are like. So in the end, as we end this tutorial, the final thing that the notebook implements is the getting started notebook implements is the get win percentage function. So what it does, it takes two agents, agent 1, agent 2, it can be any, the internal ones or the ones that you've implemented. Then you set up a config file. You set up configurations. As I said, how many rows do you have? How many columns do you have within the game? And in a row is another property. It's the dictionary. It's another property with a key in a row, which means that how many cells or how many bullets needs to be in a row for an agent to win. So in this case, it's 4. Next, what we do is we evaluate. Right, so there is outcomes, we evaluate. What we do is there might be a case where having the first move gets the agent an advantage. So what we do is we implement a splitting mechanism where we half of the time agent 1 is the one which makes the first move, and the next time agent 2 is the one which makes the next move. So this 2 outcomes, so it's a list. It's a number. So yeah. So this is how the outcomes would then be generated, and then you will have a count, and it's pretty simple. It's pretty interesting. This gives you a very brief and very interesting understanding of how reinforcement learning works, right? So it gives you an in-depth analysis. People talk about reinforcement learning and it sort of seems like very huge or very diverse or very complicated thing, but in the back end, it's all your thinking and it's all your training of the models, and it's all understanding how you evaluate your environment and how you train your agent in a way that it wins most of the times. Thank you so much for your time. It was very interesting after a very long time. Hope to see you soon again. Bye bye.